And with that, we're moving into the main presentation, and I will stop sharing now, Joey, so you can share about how to jump in right away.
Okay, well, what I'm going to do is I'm going to begin with a musical number, a really quick one, just to warm the audience up. I was going to get a job, but then came AI. I'm now an unemployed slob because of AI. I'm hiding from Terminators, yeah, you know why. Yeah, hey, because of AI, because of AI, because of AI.
Well, on that cheery note, I can't wait to see the content. Thank you, Joey. We're looking forward to the presentation. I'm going to go on video and audio mute, so all the attention is on you. Take it away.
Okay, all right, well, let me share. It's time to test screen sharing. So let me do that. And let me set up the slideshow. Let's see if presenter view is working properly. Let me know if that's the case. The chat window's disappeared on me, but let's see.
Looks good.
Okay, perfect. All right, well, hey, welcome to AI, how to jump in right away. And anyways, you can get all the stuff online here. What I've done is I've created some shortcut links so that you can get the slides. You can get a couple of Jupyter notebooks, one for Eliza, which I will explain shortly, but feel free to grab that. Do a screen capture if you want. It will be handy. And then one for the Jupyter notebook containing the exercise that I'll walk us through. So they're all here, globalnerdy.com. That is my own personal technology blog. It's been around since 2006. I write a bunch of things there, including compiling a weekly event list of technology, entrepreneur, and nerd things that happen in Tampa Bay. So there we go. Make sure I'll give you a couple more seconds to do a screen capture if you need to. And then I'm going to jump to the next slide. And basically that is, you know what, if you only remember four things from this talk, because this will go fairly quickly, the four things I want you to remember are A, wow, our brains are really amazing computers. For 1,300 grams of gray goo, they do a fantastic job compared to what we require in order to do some of the to do what currently right now are parlor tricks that form AI. These machines require a lot of power, and many of them require a lot of space and generate a lot of heat. Whereas our brains pretty good, pretty creative, and they run on sandwiches. So be impressed by that, by the intelligence in your head. The other thing, yes, is that at least right now, and maybe this might be a good definition of intelligence in general, definitely artificial intelligence. Yeah, it's largely pattern recognition. And what I like to say sometimes is that, yeah, sure, AI is parlor tricks, but some parlor tricks are useful. Another thing is that more than ever, especially given some of the people who are currently spearheading AI and the big drivers right now, we're going to need more people who actually do care about ethics. I'm going to talk about that in a little bit. And then finally, is it too late to learn? Definitely not. In fact, it's never really too late, but right now we are still in the early days. 100 years from now, what we are doing is going to seem incredibly laughable. We are going to be like cave people who haven't even figured out how to bash the rocks and turn them into knives. We're just simply, at this point, we are still using plain old rocks as tools. We haven't even learned how to sharpen them just yet. But before I begin, really quick introduction. I am Joey deVilla. I, until February, was a developer advocate for the identity company called Okta. I'm a mobile developer by trade, and I was a co-author of an iOS development book. I like talking to both people and computers, which is why I'm a developer advocate. I've done work for Tucows, Microsoft, and Shopify. And I learned Python, the preferred programming language of AI, at Burning Man. I had a week to learn it, and I was on vacation at the time at Burning Man. And when I came back, I had to be ready to hit the ground running. So I learned it there. And any programming language you can learn at Burning Man is a good one. And then finally, I'm originally from Toronto, Canada, and as a result, I'm the second most featured accordion player to ever appear on MTV Canada, the first still being Weird Al. And more power to him. Oh, one more thing in my career, I really tried to make Windows Phone happen as a developer advocate for Microsoft. That didn't work out quite well. What did work out a little bit better is the Tampa Artificial Intelligence Meetup here in Tampa Bay. I co-run it with my wife, Anitra. And yeah, it's very well attended. We get to have a lot of fun. We try to make it practical and actually build apps there. My hope is that whenever I try to make a presentation, I try to make sure that you can walk away with a working app, and that is one of my intent. That's my intention here. So before that, this is a good one for those of you who've played D&D. You already know the difference between a centaur and a minotaur. They are terms that we actually have in the AI context, and I'm going to talk about them right now. So this is a centaur as depicted in the Greek myths. We're talking human head and torso and body of a horse. We're familiar with that. We've probably seen it. We've probably read about it in the Greek myths, or there are some classical movies featuring centaurs. And Garry Kasparov, the great chess player, he's now a bit of a politician. He coined the term centaur chess, and that basically is where the human is in charge, but is assisted by a non-human part. So if you've ever used ChatGPT to create a rough draft of writing or GitHub Copilot while coding, you have been a centaur. You are still making the decisions, but you are counting on the assistance of a non-human entity. On the other hand, oh yeah, and of course, there is reverse centaur. There's the opposite, but the opposite is not the reverse centaur. The opposite of a centaur is the minotaur. The minotaur had a bull's head and tail, lower part of it being the lower body of a human. In Greek myths, the Minotaur lived in the center of King Minos' labyrinth and was killed by Theseus, who used a spool of thread or yarn. Can't quite remember what it was, but yeah, he used some string so he could backtrack his way out of the labyrinth. So for those of you who are into computer science or programming, Theseus also basically invented backtracking and pointers. But the idea of whether you are a centaur or a minotaur, at least in AI, is a matter of who's in charge. With the centaur, you, the human, are in charge. The human has the agency. The human makes the decisions. On the other hand, the minotaur has the non-human head and the human body. So in other words, you, the human, are actually being directed by the machine. The machine is in charge. And the human has to abide by the machine's decision. One of the problems with being a minotaur is that, of course, you can be ordered by machines to do things that you may not want to do or may be bad for your health. I feel bad for soldiers of the future because there are many military thinkers who have suggested that the future of warfighting is not soldiers ordering machines around. It is machines ordering soldiers around. And in fact, there's an article, and it's linked to in the notes in the slides. So if you download the slides, you'll find it. There's an article called Minotaurs, Not Centaurs, The Future of Manned-Unmanned Teaming, and it does not bode well for the soldiers. I feel really bad for our warfighters. And of course, we've had Minotaur warfighting scenarios in science fiction before. There is a classic Star Trek episode where they put the Enterprise under the command of a computer called the M5, and things go terribly, terribly wrong. So my hope, for me at least, is that ideally I would like my relationship with AI to be centaur when possible and minotaur only when necessary. I think that's the same for you. Let me know if you disagree, but I like the centaur where possible, minotaur where necessary kind of relationship. And there are 4 reasons why it's not too late to join the AI party. The first one being that it's been simmering around for a long time. It dates back to the 1960s. In fact, generally, when you talk to people in the 1960s who were into computer science, they were still thinking not of writing applications or systems that allow you to share cat pictures. They were thinking of computers in terms of electronic brains, and they were trying to mimic. A lot of them were trying to mimic human thinking. And the first programming language one of the first ones to hop on the scene was Lisp, shortly known as short for list processing. It is fantastic at manipulating symbols, which made it really good for what they used to call classical artificial intelligence. Most programming languages these days are some descendant of Lisp. There are still a whole bunch of ideas from this 1960s programming language that live on in today's programming languages, including Python. And that's largely because Lisp has a strong mathematical backing. Because Lisp was the original AI programming language, there came a thing called smug Lisp weenies. These are people who believed that Lisp was going to always be superior to all programming languages, and good God, were they smug. The only languages that Lisp people ever respect are those that are really similar to Lisp. So you may see here languages like Scheme, where they go, okay, these are all right languages. There's a reason we don't program in Lisp anymore, and you'll see it at the bottom of the screen right there. That is code for displaying the lyrics of the song 99 Bottles of Beer on the Wall. And it is really, really hard to read, and Lisp uses a functional notation which requires everything to be expressed as a list of 2 items, the head and the tail. And what ends up happening is it becomes this really deeply indented list of parentheses, and it becomes really hard to read. So we don't really program it anymore. One of the old definitions of AI is that a programming problem is considered AI until someone solves it, and then it's not AI anymore. And I think one way to think about it is there used to be a thing called multimedia software. That was software that had a mix of text, graphics, sound, and video. That used to be its own category. We now just call that software, or even web pages, because it's just become part of computing these days. It's the same deal with AI. There's a whole raft of problems that used to be in the realm of AI, including chess, until somebody figured out how to write a chess program that could take on at least a reasonably talented chess player. It used to be an AI problem. Now it's a game programming problem. So some things are AI until they're not. Now, classical AI is the kind of AI that predates neural networks. And for the longest time, that's all we knew. And what they were programs that defined a search space of all the possible solutions to a problem. And the trick was to write some code that would find the best solution node within that space. So typically what would happen would be that you would create a you'd specify the problem as a kind of tree, or you'd put all the possible solutions into a tree structure like the one I'm showing on the screen here, and you would write an application that would try and search that tree space, which could be really large, and try to find the most efficient solution possible, the solution that found the part of the tree graph that found the solution first. And the first AI systems, of course, as a result, tended to be rule-based. And they were just giant collections of, if a particular thing happens, then respond this way. This is a very simplified example here, but I'm sure that you would get it. Basically, yes, if a person's favorite artist is Taylor Swift and the current season is autumn, their likely coffee choice is probably pumpkin spice latte. So Eliza was actually the original chatbot, developed by a computer scientist by the name of Joseph Weizenbaum. He worked on it from 1964 to 1966, and it's named after Eliza Doolittle from the play Pygmalion or the musical My Fair Lady, whatever you prefer. And it used a bunch of scripts to simulate conversations. And the most popular script was the doctor script. And the doctor script simulated a Rogerian psychotherapist. And Rogerian psychotherapy is basically the kind of psychotherapy where the therapist gets you to talk out, and the psychotherapist usually goes, and how does that make you feel? You know, that sort of thing. So Weizenbaum figured, you know what, that would be a fairly easy thing to simulate, even with the limited programming and processing capability of mid-1960s computers. Eliza ran on a computer that ate up an entire room. It was an IBM 7094. It could barely address 32K of both ROM and RAM, had a 36 data bus, and costs about $34 million in present day money. So that is a lot of power. And it was implemented in a programming language called MadSlip, which was basically a combination of an ALGOL-like language and a Lisp-like language. ALGOL is the programming language that kind of, most of the programming languages today, they inherit ALGOL's kind of structure. ALGOL was short for algorithmic language. So Eliza was kind of basically written in, I like to call it proto-Python. And Weizenbaum noticed that when he had people sitting down and talking to Eliza, and by talking, I meant sitting down at a terminal and interacting with the Eliza program, he found that even then, despite the fact that we would kind of think of the dialogue it produced as hokey and see-through, a lot of people actually believed they were not talking to a program, but another person on another teletype somewhere in another room. And Weizenbaum actually said, I had not realized that extremely short exposures to a relatively simple computer program could induce powerful delusional thinking in quite normal people. I don't even know what he would think of ChatGPT today. And let me see if I can't fire up Eliza right now. Now, I noticed that a bunch of people here may be having trouble running Jupyter Notebook. Typically what you do after you've installed it, if you're following the install instructions, is you would need to go into your terminal and basically, let me see here. You should go into a terminal program. For those of you on Mac and Linux, you should run the terminal application. For those of you on Windows, you want to run either command line or Windows PowerShell, and you want to type in the command Jupyter Notebook. And then enter that, and what you will be presented with is this interface right here. And what you're going to do is you're going to look for where you saved the .ipynb files. Those are the Jupyter Notebook. That's the file name extension for Jupyter Notebook. And you double click on those and you will run the application. So what I'm going to do right now is I'm going to run Eliza here. And very quickly, what Eliza does is Eliza uses, well, this version of Eliza, because I'm using a modern programming language, I'm using Python, is I am using what are called regular expressions. I am just trying to pattern match what somebody types in, and then find the match, and then just return back the appropriate response. So for instance, what I have here is I've defined a whole bunch of what are called regular expressions. These are patterns I'm trying to match against with. And what I'm trying to do is let me bump up my font size a bit. What I have here is I am highlighting here what one of the kinds of sentences I'm trying to match against, which is I struggle, followed by a whole bunch of other stuff. So I'm looking for sentences that begin with I struggle. And then if I go a little farther down here, I have possible responses, which I pick at random. So if the user enters I struggle, let's see, where is it? Trying to find it here. So I'll just do a quick search. Here we go. If the user enters I struggle, the program has the opportunity to randomly select one of these possible responses. Tell me more about how you struggle with whatever, blank, or is blank often on your mind? And the blank, basically what we do is I take that piece of whatever the user entered that followed I struggle. So what I'm going to do is Jupyter Notebook, for those of you who are not familiar with it, is like a long Excel spreadsheet, except actually it's more like an Excel column that can contain either text or code. And what I'm going to do is I have this program organized into cells. This cell right here that I've got on screen contains the pattern recognition code. So I'm going to run that. I have a cell, I have some other cells here that define some other Python routines. Basically, it's to convert patterns into recognition, regular expressions, which I use to match against the user's input. I have some extra code here to kind of reflect the word. So when the user says I, the program knows to respond with a reflective pronoun, which would be you in this case. Or if I say me, of course, it should answer with you. So I will run that. And then what I can do right now is once I run this cell, oops, that cell is already running. I can start typing and have a conversation with it. So for instance, I can say, I struggle with understanding Python. And then it responds back, tell me more about how you struggle with Python. I don't understand the syntax. And here, let me bump up the font size a bit so you folks can read my screen a little more easily. And it asks, why don't you understand the syntax? So I'll type in something like, maybe I'm not smart enough. I'm trying to answer these questions like a doubtful person. Anyways, let's see now. Okay, but can you elaborate a bit? Oh, by the way, I see in the chat that somebody says they can't they're getting a problem, can't import GTTS. What you can do is go back and comment it out. In other words, put a number sign in front of that line and then click play on that cell again. That number sign is going to comment out the statement to import GTTS. You probably need to install it. Drop me a line after the talk, and I can show you how to do that. But as you can see, this is proto ChatGPT. And once again, you can download this file and play around with it and kind of edit it if you like. Now let me get past Eliza here. Oh, okay. Now that I'm done, let's see, demonstrating Eliza, there are a couple of things that I want to talk about with classical AI before I talk about present day AI. And the first thing is there used to be a piece of software, and this was made in 1983. There was a company that made a piece of software that was vaingloriously called The Last One. And The Last One was supposed to be was named as such because it was supposed to be the last piece of software that a human would ever write. It purported to be able to take some simple human understandable instructions and use those to create an application. It was made by a guy who gave up sheep farming, bought a personal computer, and came up with this piece of software. And for about $600 or something like that, he was going to he would sell you this program that would run on an Apple II and convert your English spec into a working program written in AppleSoft Basic. And every now and again, somebody purports to write a piece of software that will put most programmers out of a job. It hasn't happened yet, but basically what I want to say is that the story is older than even we realize. You have to remember, this is back in the 1980s when there was a promise of what was called back then the fifth generation of computing. And it was believed that unless we put in a lot of work, the Japanese would take over the computer industry because they had the big fifth generation AI programming project. That didn't quite work out as planned. Now, for those of you who want to learn more about old school AI, the best book by far is Gödel, Escher, Bach, written by Douglas Hofstadter. It is a very thick book. Read it a little bit at a time. It is incredibly deep, but they at least make it fun because every chapter before it gets into the deep psychological computer science philosophical approach starts with a dialogue between two characters, Achilles and the tortoise. And it sets things the little dialogue the little dialogues at the start of each chapter are humorous plays that set up the chapters so that your brain is ready to have a lot of deep thoughts dumped into it. It is a fantastic read, but it will take you a while, but it is great. I highly recommend it. Uh, the other thing to know is that AI is moving fast and breaking itself. This is actually the story of the talk that led to this talk. And what happened was back in November 17, I was invited to speak at a conference in Austin, the SIBO Navigate conference. That's where I met Jay. And that happened 2:10 p.m. on November 17th. And very shortly after it, Sam Altman got kicked out as the CEO of OpenAI. That happened in incredibly quick order. And after that, they set up an interim CEO. And I posted this graphic online going, how long is this guy going to last? Will he last longer than a head of lettuce? This was an exercise that they did when Liz Truss was Prime Minister of the UK. She did not outlast the head of lettuce. And neither did Emmett Shear, the interim CEO of OpenAI. And in fact, Sam Altman has returned. And yeah, there was a lot of infighting in OpenAI. It was very ugly. There's still a lot of bitterness going on. Nowadays, Sam Altman is saying he wants to raise $7 trillion to build AI chips, keeping in mind that in 2023, the US government's total spending was about $1 trillion less than that. So where he's going to raise the money or what kind of time horizon he's planning, it's a little hard to tell. Let's see now. And then lately, here's the new challenge for OpenAI. There are a lot of shady people in AI at the moment, and it's something I want to talk about a little bit later on. But this is very recent news. The person in charge of their $175 million open source fund apparently did not exist. Nobody knows who's in charge at the moment. There are other people who are planning on building their own AIs. Not all of them are pleasant. And of course, this is actually not last week. I forgot to update this slide. This is last month now. But one of the big researchers at OpenAI has left. And in fact, nobody knows what his next big thing is. He has made some interesting YouTube videos, basically on how to build AIs. They are fantastic videos to watch. Andre Karpathy. Do a search for the name. You will learn a lot by watching his videos. But we have yet to see what his next plans after OpenAI are. And of course, oh yes, Sora. Totally forgot about that. Sora, of course, is OpenAI's new technology that will take text and create video. It still needs work. For instance, here is a video called Chair Architecture. Notice, Chair Archaeology. Notice what happens. It's not quite there yet. It is very surreal. It is a little creepy. I do like the way the chair kind of floats and then walks away. The other problem is there are a lot of people who are planning on building applications based on OpenAI. The problem is that OpenAI does own the engine underneath it and can easily take over your project, or build a better product, since they actually own the engine that your project is based on. So that's another challenge about getting into AI. Now, I'm going to try and get through this fairly quickly so that I can show you an application and how we build it. And basically, that is, I want to talk about how AI requires more than just boot camp skills. You can't go to a programming boot camp and just simply hope that you will that you'll have enough to start do your own AI work. The first thing, of course, is to know that, yes, you're going to be using a programming language that's been around for a while, not a hot new programming language, but one that's been for a while. And sometimes new technologies are driven by ancient programming languages. The original iPhone was driven by a programming language called Objective-C. At least originally, that one dates back to about 1980, despite the fact that the iPhone was 21st century technology. It's the same thing for AI. AI is largely driven by the Python programming language. A lot of people program AI in Python. Python's been around since 1991. Let's see that and a couple of other languages have popped up since then that have threatened to make it extinct. When Ruby was a hot new programming language, or at least was making a big splash, and Ruby on Rails was a big thing. Everybody said that Python was doomed, but Python has a lot of scientific libraries and libraries that are very useful for data science, which drive current day AI. And that is why it's had a bit of a resurgence because of data science and AI, because it has all these libraries for it. Python is, at least currently, the preferred programming language for AI. Somebody in the Q&A asked about Julia. Julia is also quite a suitable programming language for AI. I think it's got some legs. And in fact, Jupyter Notebook, the JU in Jupyter Notebook, the programming environment that we'll be using here, the JU is short for Julia. So Julia, the PY in Jupyter is short for Python, and the R in Jupyter is short for the R programming language. So I think Julia is a pretty nice programming language. I'm not all that familiar with it. I think it's suffering from the fact that it's being eclipsed by Python at the moment, but it's very hard to predict what programming languages will do or how well they'll do. Julia may actually surprise us 10 years from now. You never know. Some programming languages that are believed to be dead seem to make a comeback. This is a classic joke about Python. It's executable pseudocode, and Python has lots of libraries. In other words, code that other people have written that you can take advantage of. And Python, of course, gave us computational notebooks. They are the Jupyter notebooks that I'm talking about. They are a way of basically having both text and code in the same document. So you can have text explaining an idea, and you can say, oh yeah, and to back up my theory or to back up my thesis, run this code. It will do something as some sort of proof. And actually, I will talk about I will do this demo after. But if you want to learn Python, check out these books. They're both by No Starch Press. They are fantastic books to learn Python with. Python Crash Course and Automate the Boring Stuff with Python. The interesting thing about Automate the Boring Stuff with Python is the author made the book available online on the web page for free. If you want an ebook version or a paper version, you can buy it. But if you just want to read it online, you can do it for free. It's at automatetheboringstuff.com. Once again, Andrej Karpathy, one of the chief scientists of OpenAI who recently left, he has a video called Let's Build GPT from Scratch in Code Spelled Out. It's 2.5 hours long. You will have to rewind a lot. and enter code and kind of rewatch things to get the idea. But if you want to learn how to build ChatGPT from the ground up, this is the YouTube video to watch. You will learn a lot. I'm still working my way through it. It's very deep. It contains lots of nuggets of knowledge. I'm going to come out of it smarter once I finish watching it and building all the code for it. AI is math-based. Make peace with that. You have to be at least better than this person at math. 21 millions, and where this person says 21 million penguins in Antarctica. Population of Ireland is 6.6 million. So if all the penguins were to invade Ireland, everyone in Ireland would have to fight off over 3 million penguins. If you can find the logical fallacy in that statement, you're in good shape. You will need to learn algebra. Linear algebra is a good part of neural networks. Yeah, algebra, but particularly linear algebra. It is not. Some people don't find it fun. I actually find it more fun than the other forms of math that I'm going to list. The reason you need to know linear algebra is because it's what we use to imitate a biological neuron. This is what a biological neuron does. The dendrites are basically the inputs. They receive a signal, and if the signal crosses some kind of threshold, it sends a message down the output, the axon, which fires off a synapse. A technological neuron basically does the same, tries to simulate what a biological neuron does, but mathematically. It takes inputs, it applies weight to those inputs, performs some kind of summation operation, and then based on that, that sum that comes out of the technological cell, we determine whether it crossed some threshold, and that determines the output. And in fact, there is this exercise where we basically go, we can use one of these biological neuron cells to tell the difference between caterpillars and ladybirds. And basically we go, the caterpillars are much longer than they are wide. So if you plot them on an XY graph, they end up in that upper left area, whereas ladybirds are wider than they are long. If you once again plot them on the same graph, they're in the lower right corner, and a single neuron is very, very good at distinguishing between the two. And once you combine a whole bunch together, in fact, this is how a neuron does it. A technological neuron does it by creating a function that knows how to divide these two categories of objects together. And that single neuron used to be called, and I think they still are called, they are called perceptrons. There are two scientists from MIT in the 1960s who wrote a seminal book on the subject, Marvin Minsky and Seymour Papert. The perceptron is basically the basis of what we now know today as a neural network, basically a combination of perceptrons linked together in a kind of network that can do fancier calculations than simply dividing a graph into two different categories. And these neural networks are basically the basis of things like ChatGPT, and they are a rough approximation of how the nerve cells in our brain allow us to think in the first place. The other math you're going to have to learn, of course, is calculus. The good news is it's the easy calculus. I know some of you are probably screaming right now, but yes, it's only differential calculus. It's used for calculating error, which allows us to teach a neural network basically by having it learn from its mistakes. So knowing calculus is good if you want to get much deeper into neural network programming. And calculus is the math of change. It studies the rate of change of things. If you look at a speedometer, you are actually seeing calculus in action, because a speedometer measures speed, and speed is nothing more than the rate of change of distance. That is calculus, at least differential calculus. And we train, like I said earlier, we train neural networks by presenting them with training data. And when they get things wrong, we calculate the error and feed it back into the neural network saying, you were wrong by this much. And the way we calculate the error is by using calculus. Probability and statistics is also very important. A lot of neural networks, a lot of data science, and of course, machine learning these days is statistics driven. See if you can figure this out. I'll give you a couple of seconds. This is a probability and statistics exercise. You've probably just look at it for a moment. Remember, it's an 80s song. You probably know what this is. If you're still having trouble, ask me in the Q&A and I'll answer. It's also helpful to know this new branch of mathematics called information theory, and it's studying things like probability distributions of groups of things for similarity, and studying entropy, basically the noise or disorder in a system, and also information encoding and decoding. This is a relatively new branch of math, but knowing at least a little bit of it is going to be helpful if you plan to get much deeper into AI. And I recommend these books for getting into math gear. If you download the slides in the speaker notes, there are links to all these books. And one of the big challenges that you're going to face when working with AI, of course, is explainability. And by explainability, I mean how you explain how the AI came to that result. In rule-based systems, old school AI, it's very easy to explain how an AI came to that result. I can actually point to the line of code in ELIZA where it went, okay, it responded this way because it pattern matched against this line where I said I'm having difficulty with. With deep learning models, the way it came up with the answer is buried deep within the programming of all of the neural network and the data within it. And it's very, very hard to explain how an AI came to those results. This is going to be one of the big challenges in AI for the next couple of years. And yeah, there's a lot of reading you've got to do if you want to get into AI. If you read only one non-programming modern AI book, it's this one. You Look Like a Thing, and I Love You. It is based on, the title is based on an AI attempting to generate pickup lines. Janelle Shane, who writes the AI Weirdness blog, is hilarious, and the book is great. The audiobook, they hired a great reader she does a fantastic job reading the book. If you like audiobooks, get the audiobook version of this. Also worth reading, these three books. They are very good. O'Reilly's Analytical Skills and AI for Data Science. Is the algorithm plotting against us? I love that title. And if you are more into product management than development, the AI Product Manager's Handbook by Pact at the moment is probably the best book on the subject. If you want to end up on a watch list, read these books. Actually, these are scary. I have read both, and they talk about the ethical minefields that AI introduces. Man-made women is downright scary. Did people not watch that Futurama episode that says "Don't date robots"? Apparently, they didn't. And then the Palgrave Handbook of Malicious Use of AI and Psychological Security probably will be necessary cybersecurity reading as bad actors start getting into using AI to break into systems. Lastly, I would say keep an eye on Mojo. Mojo is a programming language that builds on Python. You can program it in plain old Python, but if you use the extra language features that Mojo gives you, you get amazing acceleration because it takes advantage of the fact that it's a compiled language, and it goes a long way to trying to figure out what kind of hardware is on your machine so that you can so that what it can do is it tries to take advantage of it. If it finds a GPU on your computer, it'll go, oh, hey, a GPU, I can use that to make my AI faster. Or extra cores on your chips, I can use that to make it faster. This is fantastic new language. Keep an eye on it. Mojo, M-O-J-O. It is made by a software company called Modular. Chris Lattner runs it. He is the person who created the Swift programming language for Apple. And also created the LLVM compiler, which is a favorite of a lot of programmers. last but not least, AI needs some good people. Let me just jump ahead to, you can read this on your own. I just want to jump ahead to something really quickly here, rather than the Boston housing data set. I want to skip past that because I want to have a little time to show you the sweater program. Remember that guy I talked about who developed, who wrote the book on perceptrons, the foundational element of neural networks, Marvin Minsky. He was on Epstein Island. Epstein went to a lot of people, and Epstein liked to fund a lot of scientific things. And yeah, Minsky went along with that. That was downright terrible. There were a lot of scientists who did at MIT and other places who did take Epstein money, but then did actually give it back and recant it and basically said, you know what, there's a lot of nerd tunnel vision. A lot of people were not paying attention to the ethics. They were just interested in using the money to forward their own ambitions and forward the science. Mark Andreessen, head of Andreessen Horowitz, a long time ago, he helped make the what became the Mosaic browser. He's now a VC. He really does not like the idea of AI regulation, and he has some terrible ideas. And in my opinion, a lot of his opinions are downright terrible. He recently wrote something called the Techno Optimist Manifesto. It is based on the Futurist Manifesto, and the Futurists ended up joining the fascists in Italy pre-World War II. A lot of ugly things happened. Yeah, he kind of sounds like Doctor Doom from Marvel Comics. This is the Futurist Manifesto I was talking about. What I've got here on the side of the screen is an actual line from the Futurist Manifesto. This is the sort of ugly proto-fascist thinking that Andreessen seems to be embracing at the moment. He directly quotes the Futurist Manifesto and the Techno-Optimist Manifesto. It is downright terrible. You also get people like this in the end once you start hanging out with them. Thankfully, we have Dr. Timnit Gebru, who is fighting on the side of right for AI. She and a friend, Dr. Emil Torre, came up with this acronym TESCREAL, which basically summarizes the mindset of a lot of AI people: transhumanism, extropianism, et cetera, et cetera. All that stuff is explained in the notes. I think TESCREAL sounds too cool, so I rearranged the letters and added a few things to call it rectal set instead, because their heads are up their asses. Once again, this is going to be explained in the notes. But basically, let's see now. One book I'm going to ask you to read, you should actually read. Douglas Rushkoff writes really great stuff on writes really great stuff on technology. He's got a great book called Survival of the Richest, which kind of talks about the tech bro mindset that I'm trying very hard to fight against. The reason I want more people to get into AI is because I'm hoping they're a better crop than a lot of the people we have right now. As tech and AI get increasingly intertwined with everyday life, I want this in mind. We need people who give a damn about ethics. And with that, what I want to do is very quickly, if I can, let's see, walk you through the Jupyter notebook that I provided here, AI, how to jump in right away. Jay, how are we doing for time?
Doing real well. It's 7:12.
Okay, all right. Well, this is a Jupyter notebook that you could run on your computer. And like I said earlier, a Jupyter notebook is basically a piece of software that allows you to have text, which I have here. I've got a whole bunch of explanatory text that walks you through the process of setting up an OpenAI account. You're going to need that because we're using OpenAI to power this application. So what I'm going to do is I'm going to assume that some of you have managed to install something, or I'm going to pretend that this is sometime in the future. You're sitting at home, you're trying it out on your own. Notice here, I've got one cell here containing text. I'm going to bump up the font size a little. And then I have this cell here. Once again, think of Jupyter Notebook as a long Excel column. Some cells contain text, some cells contain code. What I'm going to do is I'm going to run this particular cell of code. All this is going to do is it's going to create an OpenAI object, and then I'm going to call on it to talk to OpenAI. So to run a cell in Jupyter Notebook, all you have to do is highlight it, just click anywhere in the cell and press the play button up here. Now, I've already run this program, so basically the message I got was, all right, you know what, this thing's already loaded. Let's try running a scaled down version of ChatGPT. So this is what I'm going to do. That's what the text says. I'm going to go to the code cell that lets me run a scaled down version of ChatGPT. I'm going to highlight it, and then I'm going to run it. And what happens here is I have a little prompt. It's a little hard to pick out, but the prompt says, say something. And what I'm going to do is I'm going to ask ChatGPT a really simple question. What's the fastest land animal? And it's going to do some crunching. And the object I get back is this thing right here. This is the text representation of what is called a chat completion object. Every response from GPT is called a chat completion. And I get all kinds of information. So I get told, yes, why did it stop delivering a chat completion? And the reason, of course, it says stop. In this case, basically, it's going, the reason I stopped spitting out data was because I was done. And then embedded somewhere in here, here it is it's inside this parameter called content. Let's try that again. The fastest land animal is the cheetah, which can reach speeds of 70 miles per hour. And I explained what all that Python did and the parameters that we are sending to ChatGPT. But if I scroll down a little farther down here, what I'm going to do is I'm going to say, give me only the content part of what I got back from ChatGPT. And once I run that cell, this is the answer I get. So in other words, this is the content part of what ChatGPT gave me back. So it's just it's basically the thing that we as humans are most interested in. The fastest land animal is the cheetah. A little farther down, I've created a little function that lets me call ChatGPT. Just send it a one-line, basically a one-line thing that lets me ask ChatGPT a question programmatically and get a response. So that's what create completion does. So by running this cell, I'm defining that function, and then I can call that function right here. So create completion. How much does the Earth weigh? So what this does is this lets me run. If I run this function, it does all the work contained in this cell and spits out the answer right here. The Earth weighs approximately 13 times 10 to the 24 pounds. Now, GPT itself, the OpenAI engine, accepts a parameter called temperature, where it's a value between 0 and 1, and where 0 is completely predictable and stead, whereas 1 is whereas 1 gets a little more random and wildly creative. I'm going with the default right here, create completion. So I'm going to set completion so that the default temperature is 0.7. A little bit inventive, not so staid. And if I run this program here, what I'm doing is I'm asking GPT for 2 one-paragraph descriptions of characters for a young adult novel set in the age of pirates. So I'm going to run that. And I get 2 descriptions here really, really quickly. By the way, somebody asked in the tutorial how to import the .env file that you made with your OpenAI key. It should be in the PDF linked in the chat. There's a PDF I put together that you could look at prior to this that you could look at prior to this talk. That should be there. If not, connect with me on LinkedIn, drop me a line. I'm happy to walk you through the process. The other thing I can do is I can crank up the temperature. Let me see if I can get to the end of the line here. Okay, set in the age of pirates. And then let's see now. Let me set the temperature to 1.5. Let's see if this will work. Okay, it's going to crunch away. So this is a slightly wilder version of the output. Some of the formatting gets a little stranger, and once I get it, let me see if I can't set the temperature a little higher. Temp 1.8. And sometimes when you provide OpenAI with a higher temperature, it gives you wackier and wackier results. It also takes longer to process. Notice that it's not responding as quickly as before. What we get should be really, really interesting. Gotta love Murphy. This is the Murphy's Law of running code live. Let's see what happens. Does anybody have any questions in the meantime? Feel free to type them in the chat. I see no Treasure Island. Give it enough input. Oh, there we go. Oh, it timed out, I think. Let me try 1.5 one more time. Just to, oops, no. 1.5 run. We'll let that run in the background. But yes, as far as, okay, there are values between higher than 1.5 where the output gets a little crazier or a little bit nonsensical or starts looking rather random. I am going to jump ahead. I'm just going to run these programs. Once again, you can, oh, here's one actually that I need to talk about. There is a system guidance that you can also provide to GPT. Basically, what you're doing is you can now define a couple of roles. One is for the user. Once again, that is input from the user. That is input from the user that you can provide to GPT. The other thing is the system role, and that is where you provide some additional instructions to GPT to tell it how to answer. So in this question right here, what I'm doing is I'm asking ChatGPT to explain the first law of thermodynamics. So this is the typical prompt that the kind of prompt that we've been feeding so far, but we're giving an extra message to the system. And basically we're saying, look, I want you to answer as if you were a shady used car dealer. So answer in that particular persona. These are extra instructions that the user does not see. And as a result, you get something like, hey there, buddy, and it does explain the laws of the first law of thermodynamics, but the way a used car salesperson would. What we can do now is we can use some other internet services to provide GPT with some extra information. So in this particular case, what I'm doing is I'm going to use a service that allows me to do some geocoding, get a location's latitude and longitude from a place name. So I've already installed the GeoPy module. If you run this particular cell, this will install the Python's GeoPy module for you. And I'm going to define a function that lets me convert a location name to lat-long, latitude and longitude. And if I run it, and if the system is online, yes, it is, thankfully. What I can do is if I provide it an address, I can use the system will give me back latitude and longitude. Okay, that's perfect. That's one thing I need. Another thing I can do is I can get a time at that location. So I've already installed the time zone finder Python module. And this function that I've written here lets me get what time zone I'm in based on given latitude and longitude. So what I'm doing now is I'm going to take a function, the output of my location name to latitude and longitude function, feed it Austin, Texas, and then feed the result of that function into the function that gets a time zone from a latitude and longitude. So if I run that, for instance, we know that Austin, Texas is in the time zone that is typically known as America/Chicago. And then from that, I can get the current time at that location by defining this function, get current date and name in time zone. And the way I'm doing that is by first, I get the location. And then based on the location, I get the latitude and longitude. Then I get the time zone based on that. And then I can get the time, the current time at that location. So that's what this function does. So I'm feeding functions into functions into functions. And once I do that, I get this nice little function that's very simple. Get current date and time in location, which is Austin, Texas. And it should be 7:23 p.m., Tuesday, April 2nd. I'm not going to bore you with the get the current weather part, but what I am doing, and I explain right here how I do it, I'm using the Open Meteo service. Meteo is French for weather, to define a function that lets me get the weather from a specific location that I specify by name. Open Meteo expects latitude and longitude, but I already wrote a function to translate a place name to latitude and longitude. So once I have run this cell, I can get the current weather in Austin. Let me run that right now. There we go. And I get a Python dictionary that I'm going to highlight right here that tells me what the current weather is. By the way, the temperature is in Celsius. I didn't write a Fahrenheit conversion thing, but that's 19.6. That's about 68, 69 degrees. So it's pretty nice. What I can do with that weather report now is I can create a weather poem prompt where I create a prompt based on the weather at a particular location. So I'm using all these functions, I'm building on top of them. From the location name, get the latitude and longitude, feed the latitude and longitude into the weather system, get the weather back, extract the contents from the weather report, and form a sentence out of it. So let me run that function, create weather poem prompt, and I'll feed it Austin. And this is a prompt. What it does is it gets the weather in Austin and creates a prompt that I will then feed to GPT, asking it to create a poem. So this is an instruction saying, this is the weather, this is the date and time, create a poem about this. The poem should also suggest what one should wear for this weather and whether they should wear a sweater. So I'm going to run this function and test it right here. Create weather poem for location, feeding it the city, Austin, Texas. And this is the poem. Under the clear sky of Austin, so bright. Do I need to wear a sweater? No. Actually, at 68 degrees, my mother-in-law would probably want to wear a sweater anyway. She likes it a little bit warmer than that. What we can do as well is we can take DALL-E and I can say, look, let me write a quick little function that creates a DALL-E image based on a given description. So I'm going to run that right now. I'm going to define that right now. And as a simple example, actually, this is create a DALL-E image, pug dressed up as a witch, but I'm going to jump to create weather image. So what I'm going to do is I'm going to define this function right here. What it does is it gets the weather at a specific location and then forms a prompt saying, draw me a picture of the weather at this location, given that the cloud cover is like this, and include people dressed appropriately for the weather. So I'm going to run that function and we're going to test it by running it on Austin. It takes a couple of seconds for DALL-E to generate the image. Let's give it a moment. Come on. Gotta love live coding. So basically what's happening is I did send the prompt to GPT, which is routing it to the DALL-E system. There we go. And DALL-E generates the picture, giving me a URL where the picture is located. If I click on that, there we go. This is a picture of the weather in Austin right now. And since the DALL-E has been also told about what time it is in Austin, it generates it's generating a sunset. one last thing. Let's see if this works. We can also have a system speak the weather. I'm using the 11 Lab system of text to voice. I am going to try and get it to speak the weather. Let's see if it works. Takes a moment to process the request and then generate the sound.
weather in Austin, Texas is clear sky with a temperature of 19.6 degrees C, 0% cloud cover, and 39% humidity. The current date and time there is 7:28 p.m. on Tuesday, April 2nd. Create a poem about all this. The poem should also suggest what one should wear for this weather and whether they should wear a sweater.
Okay, that's right. It spoke the entire prompt. Anyways, all this is inside the Jupyter Notebook that I provided for you. It is annotated, so you can explore it, you can learn about it, you can noodle with it, and you can incorporate it into your own AI applications and experiments. That is my presentation. If anybody has any questions, fire them in the chat. And Jay, yeah, feel free to come online.